Hello everyone. Today we will discuss about the neural network. What is neural network? A neural network is a computational models inspired by how the human brain processes information. It consists of layer of interconnected nodes or neurons. Highlights its importance in solving complex problems like image recognition, speech recognition, and natural language processing. Let's talk about its key component. We have first we have first architecture, in which we have input layer. This layer accepts raw input data, for example an image in the MNIST dataset is represented as a grid of 28 cross 28 pixels. Then we have hidden layer. This layer processes the input by applying transformations and learning complex features. Next we have output layers. This provides the final predictions or classification from for MNIST. We have 10 inputs neurons, one for each digit. Second we have weight and bias. Second we have weight and bias. Weight and bias determine the importance of input while biases adjust the model's predictions to better fit the data. Third we have activation function. Explain this purpose. Activation function introduce non-linearity, enabling the network to learn complex pattern. Mention types like sigmoid, good for probabilities but can slow training due to vanishing gradients. ReLU, efficient and commonly used, it outputs 0 for negative inputs. Fourth, we have forward propagation. This is the process where input data flows through the network layer by layer, and each neuron applies weight, biases, bias, and an activation function to compute outputs. Fifth, we have background propagation. This is the learning phase where the models adjust weight to minimize error. It uses the gradients of the loss function to update weight. Step in implementations. Next we have loss functions. Measure how far the predicted outputs are from the actual outputs. Common loss functions: mean squared error, MSE for regression tasks, categorical cross topology for multiple class classification task. Next, we have the explanation of the code, in which we have data preprocessing. Normalized data, we scale pixel values to the range 0 to 1 for faster convergence. One hot encoding, this converts label into a binary format. For example, the digit 3 becomes 0001 00000. Then we have model architecture. Our neural network has three layers: one input, two hidden layers with ReLU activation, and one output layer with softmax activation. Next, we have compilation. We use the Adam optimizer for efficiency and categorical cross therapy. Loss, because this is a multi-class classification task. Training. We train the model for 10 with a batch size of 32 using 10% of the training data for validation. Third, we have evaluation. The model achieves a high accuracy, typically over 95% on the MNIST test sent. Fourth, we have prediction. Fourth, we have prediction. After training, the model can classify handwritten digits accurately. For example, it predicts the correct digit for unseen test samples. Now, let's see the code. We have demonstrate application of neural network using Python. Step 1, import required libraries. Step 2, load the MNIST datasets. Step 3, pre-process the data. Then normalize pixel values to range. Sorry. Step 3, pre-process the data. Normalize pixel values to range between 0 and 1. Convert level to one hot encoding. Fourth, define the neural networks models. In step 5th, compile the models. And in step 6, train the models. Step 7, evaluate the model on the test data. And in step 8, predict on new data. And then display actual levels for comparison. Now let's run our code. Here you can see training the model is running. Here you can see the epoch 1 upon 10, 2 upon 10, 3 upon 10, 4 upon 10, and so on. Now, now let's talk about the advantage of neural networks. They are versatile and can model complex patterns. They perform well on a structured dataset like images, audio, and text. Second, limitations. Neural networks require large amount of data and computational power. They can overfit it, not regularized property. Third, scalability. We can extend this model to more complex architecture like convolutional neural networks CNS or image data or recurrent neural networks RNNs for sequential data like text or time series. Here are some observations. Accuracy. Neural network perform exceptionally well on structured data like MNIST. Test accuracy should be above 95% for this basic model. Scalability. Neural network can be extended to more complex architectures such as convolutional neural networks or image data or recurrent neural network. Model tuning. The number of hidden layers, neuron activations, functions, and optimize can be adjusted to improve performance. At last, we will conclude our topic that neural networks are powerful tools for solving complex problems, and their application to the MNIST datasets demonstrate their ability to learn and classify patterns efficiently. They are at the heart of many advanced technologies for self driving cars to personalized recommendations. Thank you for watching a video, and I hope you understood the topic.